What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at outliers, and these are extraordinary results in a data set. The definition of an outlier is something that lies outside, outlier, of the data set, so it's something we wouldn't expect to happen. When we're talking about humans, something like height could be an outlier. Most of us are around probably 5'8" to 6'2", but then if you went to an NBA arena and saw a 7'6" Yao Ming, you'd be like, that guy is unbelievably tall, so he would be an outlier in our data set. One of the hardest things to do without mathematics is to concretely, objectively say that something is true or false. Sometimes you can have a lot of subjective or personal interpretation that decides whether or not that is true. In this example here, we've got 5 scores, 4 of them are pretty close together, and one, that 3, is pretty far away. So if you don't have a mathematical way to say, is this an outlier? Some people might say yes, and some people might say no. So learning how to communicate effectively so everybody is 100% on board with the same information is really important. Have a look at this one and by yourself see if you can work out whether or not 3 is an outlier at the end of the lesson. So it kind of looks like we've got 2 formulas here, and that's because an outlier could either be a very low number or an extremely high number. Either one is still an exceptional number that falls outside of what we would think could happen. For the low numbers, we're looking at Q1, or the lowest 25%, minus the interquartile range times 1.5. And then the upper bound is almost the exact same, but just with a plus. We're taking Q3 plus the interquartile range multiplied by 1.5. So because we are using the interquartile range, what we're looking at is the middle 50% of scores. We're really honing in on this. And then we're trying to see, is the outlier so far away from the meat of the data curve that it makes it absolutely exceptional? For this reason, if you've got numbers that are really close to each other in that middle 50%, a number that's really close could still be an outlier because the gap isn't that far between the Q1 and Q3 values. On the flip side, if you had a very variable data set with numbers that are really far away, a number that could seem like it's heaps far away from the middle might not be an actual outlier. Just having a look at this example here, 3 and 6 might be outliers. There seems like there's a lot of 5s. That's what we would expect would happen on the next one. But a 3 or a 6 might or might not be an outlier. Compare this to the other numbers that are really, really far apart. But these numbers might not be outliers. 2 and 98 probably aren't an outlier in this situation because we just have really variable data. So for this example here, we've got to find the median first, and we're just going to do that by crossing off our values. This is in order to find Q1 and Q3. Once we cross those out, we can find the median is 44, but that doesn't really matter. We're just looking for those 2 quartiles. Doing the same thing to find the quartiles, I get that 37 and 48 are my quartile marks. That means the interquartile range is just Q3 minus Q1, which is 11. So from here, I'm trying to work out whether or not any of these data points are an outlier. I'm actually not going to check the high ones. Because the highest number is 50 and I know the median is 44, I'm pretty confident that's not going to be an outlier. We can check it just to be sure, but I'm very confident the only number here I'm looking at is that 20. That means I've got to use Q1 minus the interquartile range, which is 11, times 1.5. If you just throw this into your calculator, it gives you the answer of 20.5. So that means that any number below 20.5 is an outlier. So that means in our example, 20 is an outlier, but 21 wouldn't be. I know it seems like a really silly cutoff, but you have to have a cutoff somewhere, and that's what this formula determines. So these are actually even easier from a box and whisker plot because we've already got all the information we need in order to get this right. Because we're only looking for 2 quartiles, Q1 and Q3, we don't need to look at anything else. In this example, we're trying to find out if a professional swimmer's heart rate is an outlier compared to the general population. So this woman's heart rate is 27, and we're trying to find out whether or not that is an outlier. It seems like a number that's incredibly low. Check your own to find out if you're even close, but it might not statistically be an outlier. So all we're looking for is the Q1 and Q3, these 2 red dots. Finding the IQR is really easy from here. 90 minus 60 is equal to 30. So we've just got to work out, is this an outlier? Again, only using that Q1 value. We don't care about the high numbers. So this is pretty cruisy. 60 minus 30 times 1.5. 30 times 1.5 is 15. So that makes this 60 minus 45, which is equal to 15. That means 15 beats per minute is our cutoff for an outlier. This athlete has a heart rate of 27, and even though she's incredibly fit, we're not saying that her heart rate is an outlier in this data set compared to the general population. I hope you found this lesson helpful, and I'll see you later.